Greetings of the day, respected ma'am. I am Yasmina Sultana from CSCD department, and today's my assignment 2 topic is on Cauchy's mean value theorem. So let's start. And yes, I am from CSCD department. So yeah, let's see what's the question states. The question asks to state Cauchy's mean value theorem, which is short formed as CMVT, and find C for the function f of x equals to root x and g of x is equals to 1 upon root x in the interval closed bracket a comma b, which is in a closed interval of a comma b. Now let's see what Cauchy's mean value theorem states, which is short formed as CMVT. It states that if f of x and g of x are continuous on closed interval a comma b and differentiable on open interval a comma b, and g dash s, which is differentiable of f of x g of x is not equals to 0 in open interval a comma b, then there exists c which belongs to a comma b such that f of c upon g of c is equals to f of b minus f of a upon f of b minus f of a. Here f of f dash c is not equals to 0 because it will lead to infinite. Now let's look at the given function. So the given functions are f of x is equals to root x. Now after differentiating, it will lead to 1 upon root x, and g of x, which is equals to 1 upon root x, and after differentiation it will lead to minus 1 upon 2x to the power 3 by 2. Now clearly we can see that f and g are continuous on closed interval a comma b, which belongs to the positive real number, and we have f of x is equals to 1 upon 2 root x and g of x is equals to minus 1 upon 2x into root x, which is x to the power 3 by 2, which we have discussed in a previous slide, which exist on open interval a comma b. Therefore, f and g are differentiable on open interval a comma b, which belongs to the positive real number. Also, differentiable of g of x, which is g dash x, is not equals to 0 for all x belongs to a comma b, and which belongs to a positive real number. Thus, the condition of Cauchy's mean value theorem are satisfied on open interval a comma b. Therefore, there exists c which belongs to a comma b such that f of b minus f of a upon g of b minus g of a is equals to f dash c upon g dash c. Now after substituting the values, root b minus root a upon 1 upon root b minus 1 upon root a is equals to 1 upon 2 root c upon 1 upon minus 2 c into root c. Simplifying the left hand side, root b minus root a upon root a minus root b upon root ab, which is LCM we have to, is equals to minus 2c root c minus 2 root c. Further simplification yields root ab is equals to c, since a comma b is greater than 0, therefore which leads to root ab is their geometrical mean. Therefore we have a root ab is in a interval of a comma b. Thus we can see how it has been simplified, the verification of Cauchy's mean value theorem, which we can take a look on how we have simplified it before, and we can also see that how root a comma b has been satisfied it with belonging to a comma b, which is open bracket, which exists in this equation, and it perfectly fits in this state, which is f of x and g of x are continuous in closed interval a comma b and differentiable in open bracket a comma b, and as g of x is not equal to 0 in root a comma b, which we have got the result, thus it perfectly satisfies the Cauchy's mean value theorem. And thank you, Vijay Lakshmi, and for giving your valuable time.